We're going to talk about how to calculate the correlation coefficient between two variables. But before we do that, let's talk about what the correlation coefficient tells us. So let's say we have a straight line and we have points on the line. The correlation coefficient will be +1 for this situation because all the points are on a line and the line has a positive slope. Let's say this is x and this is y. It's a positive correlation because as x increases, y increases. There is a direct relationship between x and y. Now here's another scenario. Here we have points on the line, but notice the line is going down. And so the correlation coefficient will be equal to -1. As x increases, y decreases. And so in that case, we have an inverse relationship. Now in this example, the points are not necessarily on the line, but they're close to it. And so these points, they have somewhat of a linear relationship, but not exactly 1. So in this case, r is going to be somewhere between 0 and 1. It's positive because this line is increasing. It has a positive slope, but it's not exactly 1. If we were to put a number to it, it might be 0.8 or something. Whereas let's say if you have a similar line, but let's say the points are more scattered about that line, the r value will be less. It might be 0.7 or 0.6. It could be completely different, but it's somewhere between 0 and 1. But the point is this though. The closer that the points are next to the line, r is going to be closer to 1. These points, they're further away from the line, so r is going to be closer to 0 than 1 relative to this number. Now sometimes there won't be any correlation. Let's say if you have just random points everywhere. In this case, r could be very close to 0 for a situation like that when there's no apparent correlation. So the correlation coefficient really tells us the strength of the linear relationship between two variables. If these two variables have no linear relationship, r is going to be close to 0. If there is a strong linear relationship, r is going to be close to either +1 or -1, depending on the slope of the line. Now let's take a minute and calculate the correlation coefficient. So we're going to make a table containing the columns x, y, and then the product of xy, and then x squared, followed by y squared. So for x, we have the numbers 1, 2, 3, 4, 5, and 6. So next, let's put the y values, which are 2, 4, 7, 9, 12, 14. Moving on to the next column, we need to multiply x and y. So 1 times 2, that's going to be 2. And then if we multiply 2 and 4, we're going to get 8. Next, we're going to multiply 3 and 7, which is 21. And then 4 times 9, that's 36. 5 times 12 is 60. And then 6 times 14. 6 times 10 is 60. 6 times 4 is 24. When you add 60 and 24, that gives you 84. Now moving on to the next column, x squared. So we're going to square the values that we see in the x column. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Now for y squared, all we're going to do is square the values in the y column. So 2 squared is 4, 4 squared is 16, 7 squared is 49, 9 squared is 81, 12 squared is 144, and 14 squared is 196. Now our next step is to sum up each column